Dear students, today we will discuss two topics. The first is the nature of light, and the second is the assumptions of geometric optics. If we start with the nature of light, as you know, the light plays an important role in our life on the earth. So plants can store light energy into a chemical energy using photosynthesis, and after that we can eat plants and meat, and we can take these chemical energies and we can use it in our life. Also the light nowadays play an important role in communication, so we can send and receive information from different places with a very fast velocity, which is the speed of light. So different people try to understand what light is. So they try to explain the nature of the light. What is the nature of the light? So Greeks assumed that the light is particles. So the light beam consists of a stream of particles, and these particles emitted by the object viewed or emanated from the eyes of the viewer. So they try to explain how the eye works. So here the main point to me is that they assume that the light consists of a stream of particles. Einstein took the same idea. He also assumed that the particle the light is particles emitted from it is not exactly the same idea as Greek did, but he assumed that the light also consists of particles, and these particles emitted from the light source. And using this theory, he explained the reflection. So as we know that if we have a mirror and a beam of light incident on this mirror, the light will be reflected where the incident angle equals to the reflection angle. Also, if you play a football and you have a wall, if you kick the ball with an angle, the ball will be reflected at the wall, where also the incident angle equals to the reflection angles. So here the ball is a particle, so Newton took the same idea and he assumed that the beam of light is just a stream of small particles which incident with an angle and reflected with the same angle, similar to this ball. And also we can observe this in billiardo game. So now Newton, as a famous scientist, he assumed that the light consists of particles. But later, Huygens is a scientist. He assumed that the light could be a wave, or the light is a wave, has a wave nature. And as you know, this is the shape of the wave. And another scientist called Young, he designed an experiment. So he tried to make a kind of interference between two light beams. So if I have if I have a wall like this, and in the wall I have two slits, and I have two light sources, S1 and S2, the two light beams will interfere at a screen here. At the end we will find a bright area, and then dark area, and another bright area, and a dark area, and so on. And to explain this, to explain this interference pattern, he claims that yeah, the line has the wave nature, and when the difference in path between two light beams is integer of wavelengths, this will produce a bright area. But when the difference is half integers like this, so the interference between these two pulses will produce a dark area. So Huygens assumed that the light has a wave nature, and the experiment of Young proved that the light is a wave nature. So now we have two theories. So the particle theory and the wave theory. The particle theory succeed to interpret or succeed to explain the reflection process, and the wave nature succeed to explain the interference, and also succeed to explain reflection and refraction. And finally, Maxwell, he also is a physicist. He derived some equations, and he proved that yeah, the light is a wave, but the kind of this wave is electromagnetic wave. And as you know, the light consists of an electric field which is perpendicular to a magnetic field, and both are perpendicular to the direction of the propagation. And Hertz did some experiments, and he proved the existence of electromagnetic waves. So Hertz succeed to produce electromagnetic waves, and also produce to detect electromagnetic waves. And in our life today, based on the concept of electromagnetic waves, we all can make very fast communications. So yeah, in few seconds we can reach each other's on the earth. But after that, there is an experiment or an effect called the photoelectric effect. Photoelectric effect is simply when a light incident on a material, this material emits or gives or produces electrons. So now I have light incident on a material, and this light produces electric current. To explain this, if we use the wave nature of light, so the wave nature of light, or if the light is a wave from wave equations, so here we will not write equations, but using the equations of waves, we can prove that the intensity of a wave is proportional to the energy of the wave. So increasing the intensity, this means increasing the amount of incident energy. So in photoelectric effect, as we said, we have incident light, and we have an electric current. So the electrons which move in this electric current has a kinetic energy. And people thought that increasing the light intensity should increase the amount of kinetic energy of electrons, because increasing the light intensity, increasing I, is proportional to the energy of the wave. So increasing the intensity should increase the amount of energy, and when the amount of energy, incident energy, increases, the kinetic energy of emitted electrons also should increase. But they found that the kinetic energy of emitted electrons is independent of the light intensity. So whatever the intensity of the light, whatever the intensity of the light, we always have the same kinetic energy of emitted electrons. This meaning, if we assume that the light is a wave, we can't explain the idea of photoelectric effect. So the photoelectric effect is used in different applications like solar cell. So solar cell can produce electricity from light. So we can use it to convert light into electricity. But if we assume that the light is a wave, we can't explain the experimental results of photoelectric effect. At 1905, Einstein made an assumption. So he assumed that the light consists of a quantum of energy, or quantums of energy. We call it in physics the concept of quantization. So instead of assuming that the light is a wave, he assumed that the beam of light consists of quantum of energies. Each quantum has energy h multiplied by f, where h is Planck constant and f is the frequency. And he gave a name to this quantum of energy, and he called this, could be named as a photon. So he didn't use explicitly the concept of a particle, because he would like to make a new theory, not like Einstein. And he also tried to make to use a new concept, because so the wave nature couldn't explain the photoelectric effect, and he assumed that the light consists of quantum of energies. Each quantum has energy, as I said. This energy is h multiplied by f, and this each quantum of energy is called a photon. And according to Einstein's theory, the light consists of a photon, and this photon is something between the wave nature and the particle nature. And this is the reason we can claim that the light has a dual nature. Because in some experiments the light behaves like a particle, and in some experiments the light behaves like a waves. So it should be something in between particles and waves. So Einstein called it a photon. And using this theory, Einstein succeeded to explain the idea or the theory of photoelectric effect, and he got actually Nobel Prize for this very excellent achievement. So Einstein did a lot of amazing things in science, but this is one of them, and he got Nobel Prize for explaining the concept of photoelectric effect, because he was the first scientist that claimed that the light is something between the particle nature and the wave nature. So this is actually a brief overview to the light nature. And now we would like to start short introduction, or take short introduction about geometrical optics. Geometrical optics, whatever the nature of light. So here we don't care what light is, but based on observation, if you have a laser pointer, and when you make it on, always the laser moves in straight line. So here in next lectures we would like to explain or derive the laws of interference, refraction, and so on, basing on this very simple idea that always light moves in straight directions, or light moves along straight lines. Um, uh, Only the light change its direction when the light move from a medium to another medium. So in this case, the light make a refraction, and also if the light incident on a mirror, in this case, the light will make reflection. But when the light moves in the same medium, always the light moves in a straight line. This simple assumption made a branch of science. We called it geometrical optics. So always this is the rays of light. Always the light moves in straight lines, and the plane which is perpendicular to these lines called wave front. So and the definition of the wave front, so the rays of a given wave are straight lines perpendicular to the wave front. So the wave front is always the plane which is perpendicular to the direction of the light propagation. And as we said, when the light moves in the same medium, always the light moves in a straight line until the light try to propagate through a small open or a small hole. So we have three cases. If the wavelength of the light is smaller than the dimension of the hole, or smaller than this open, in this case, the light will continue in straight lines. But if the wavelength is comparable to the width of this open or this hole, we will have a new phenomena called light diffraction. So light diffraction is the change of the light propagation direction due to passing through a small hole. And the degree of diffraction actually depends on the relation between the wavelength and the width of the hole. Of the hole. If the wavelength is comparable to the width of the hole, we have a small degree of diffraction. But if the wavelength is very large compared to the width of the hole, we have a large degree of diffraction. And we said earlier that the wave, so this is the direction of the light beams, the perpendicular to the direction of the propagation, we called it wave front. So here the light propagate in this direction, and this is the wave front. But due to diffraction, the light is diffracted in all direction roughly after passing through the hole. So we have this is the propagation direction. This is a propagation direction. This is a propagation direction. If we would like to find the perpendicular plane, this is actually the perpendicular plane. So this angle is 90. This also is 90. This also is 90, and so on. So here, so the wave front has a circular shape when the light is emitted in all directions. So if the light is emitted in all directions, the wave front is like a sphere actually around. So actually this hole will work as a light source. So at the end of this lecture, I hope that you can answer these questions. So according to Newton theory, light is, please check it. According to Huygens theory, light is. So also the interference proved which nature of light interference proved, also what is photoelectric effect, and what is the consequences of the photoelectric effect. So the experiment of photoelectric effects lead to a new explanation or giving a new assumption to the light nature, as Einstein did. I hope that after this small lecture you can answer these few points. And thanks a lot, and I am waiting for your comments.